The astonishing mineral footprint. How much earth does each American use? Have you ever stopped to consider the sheer volume of raw materials that underpin our modern existence? From the concrete jungle of our cities to the tiny chips in our smartphones. Virtually everything we use, consume, and rely upon originates from the Earth's crust. A striking figure often cited by organizations like the Minerals Education Coalition, MEC, and the U.S. Geological Survey, USGS, quantifies this reliance. Every American born will need approximately 3.06 million pounds of minerals, metals, and fuels in their lifetime. This astonishing figure isn't just a statistic, it's a profound statement about our industrial civilization and the hidden processes that sustain it. Unpacking the 3.06 million pounds, a lifetime of consumption. This impressive total is not a single arbitrary number, but a carefully calculated aggregation of various essential resources. It represents the estimated per capita consumption over an average lifespan, reflecting everything from the construction of our homes and roads to the energy that powers our lives and the materials that make up our everyday products. The data is compiled by analyzing resource extraction, processing, and consumption patterns across numerous industries. Let's break down some of the key components that contribute to this massive material footprint, as depicted in the original graphic. Stone, sand, and gravel, approximately $1,358,000 lbs. By far the largest component by weight, these aggregates are the unsung heroes of infrastructure. They form the backbone of concrete and asphalt, indispensable for building roads, bridges, buildings, and other crucial construction projects. Without these fundamental materials, modern urban landscapes simply wouldn't exist. Coal, approx. 187,393 lbs. Despite a global push towards renewable energy, coal remains a significant energy source, primarily for electricity generation in many parts of the world, including the US. It's also vital in the production of steel. Cement, approx. 61,225 lbs. A critical ingredient in concrete, cement is the binder that holds our built environment together. Its demand directly correlates with population growth and infrastructure development. Salt, approx. 28,055 lbs. Far beyond just seasoning our food, salt is a crucial industrial chemical. It's used in countless processes, including the production of chlorine, caustic soda, and as a de-icing agent. Iron ore, approx. 18,368 lbs. This is the primary source of iron, which is processed into steel. Steel is an ubiquitous material, fundamental to construction, skyscrapers, bridges, transportation, cars, trains, appliances, and countless tools and machinery. Phosphate rock, approx. 12,245 lbs. Essential for modern agriculture, phosphate rock is processed into fertilizers that replenish soil nutrients, enabling the large-scale food production necessary to feed a global population. Clays, approx. 11,703 lbs. Clays have diverse applications, from ceramics, bricks, tiles, pottery, to fillers in paper, rubber, and plastics. They are also used in drilling muds and various industrial processes. While these bulk materials constitute the majority of the weight, the less voluminous but equally critical metals are where much of our technological advancement lies. Copper, approx. 930 lbs. An excellent conductor of electricity and heat, copper is indispensable for electrical wiring in homes and electronics, plumbing, and a wide array of industrial machinery. Its demand is only increasing with the rise of electric vehicles and renewable energy systems. Zinc, approx. 465 lbs. Primarily used for galvanizing steel, which involves coating steel with a thin layer of zinc to prevent rust and corrosion, significantly extending the lifespan of products. It's also used in batteries and various alloys. Lead, approx. 853 lbs. Though its use has diminished in some applications due to environmental concerns, lead remains vital for lead-acid batteries, predominantly in vehicles, and in some specialized industrial contexts. Silver, approxi. 3.44 lbs. Beyond its use in jewelry and coinage, silver's exceptional electrical and thermal conductivity makes it crucial in electronics, solar panels, and medical applications. Gold, approx. 1.2 troy-Oz. Revered for its beauty and rarity, gold is also a critical industrial metal due to its excellent conductivity and corrosion resistance. It's found in high-end electronics, medical devices, and serves as a store of value. Lithium, approx. 1.7 lbs. A rapidly growing demand for lithium stems from its crucial role in rechargeable batteries for electric vehicles, portable electronic devices, smartphones, laptops, and large-scale energy storage solutions. Finally, the category of other minerals, metals, and fuels, approximately $388,000 lbs, encompasses a vast and diverse array of resources, including aluminum for aerospace, packaging, transportation, petroleum and natural gas for energy, plastics, chemicals, rare earth elements, critical for high-tech devices, magnets, green technologies, and many more specialized materials that enable everything from medical imaging to satellite communication. The historical context. From subsistence to industrialization. Humanity's reliance on minerals is as old as civilization itself. The Stone Age marks our earliest use of readily available materials like flint and obsidian for tools and weapons. The discovery of how to extract and work with metals ushered in the Bronze Age and then the Iron Age, profoundly transforming human societies, warfare, agriculture, and craftsmanship. However, the scale of mineral consumption remained relatively modest for millennia. The Industrial Revolution of the 18th and 19th centuries marked a dramatic turning point. The invention of the steam engine, the mechanization of textile production, and the growth of railways created an unprecedented demand for coal, for energy, iron, and steel. This era laid the groundwork for mass production and global trade, linking resource extraction directly to economic growth. The 20th century witnessed an exponential increase in material consumption, driven by two world wars, the advent of the automotive and aviation industries, the widespread adoption of electricity, and the explosion of consumer goods. The latter half of the 20th century and the beginning of the 21st have been characterized by the information age and the digital revolution, which, while seemingly virtual, are incredibly material-intensive. The sophisticated technologies we now take for granted, computers, smartphones, electric vehicles, renewable energy systems, require a complex cocktail of increasingly rare and specialized minerals, often sourced from around the globe. Why this data matters. Awareness, sustainability, and the future. Organizations like the MEC and USGS don't just compile these numbers out of academic curiosity. They do so to raise awareness. Many people are largely unaware of the extent to which their daily lives depend on mining. Understanding our mineral footprint can foster greater appreciation for the resources themselves and the industries that supply them. Inform policy. Accurate data on resource consumption is vital for policymakers to make informed decisions regarding land use, environmental regulations, trade agreements, and strategic resource security. Promote responsible practices. By highlighting the vast quantities of materials required, the data underscores the importance of sustainable mining practices, including minimizing environmental impact, ensuring worker safety, and fostering community development. It also emphasizes the need for recycling and reuse to reduce reliance on primary extraction. Drive innovation. The recognition of finite resources and growing demand encourages innovation in materials science, leading to the development of alternative materials, more efficient extraction methods, and advanced recycling technologies. Address supply chains. In an increasingly interconnected world, understanding where these vital minerals come from and the geopolitical factors involved is crucial for ensuring stable supply chains and economic resilience. The 3.06 million pounds isn't just a historical accounting, it's a projection into our future. As the global population grows and developing nations strive for higher standards of living, the demand for these essential minerals will only continue to rise. This necessitates a thoughtful, balanced approach to resource management that considers economic needs, environmental stewardship, and social responsibility. Our future, quite literally, depends on the materials we extract from the earth and how wisely we use them.